Hello everyone. In this video we're going to continue on section 1.5. In the last video we talked about what formulas were and we saw some examples of them. And we even talked about like where those formulas come from and what each variable means with each of the shapes laid out. We had a lot more geometry. But in this video instead we're just going to look at some formulas and we're going to focus strictly on solving one of these equations for a particular variable. So let's look at number one. Number one, we want to solve for a. We want to get a by itself. So the way that we want to think about this in general is we always want to undo whatever is being done. So this is a plus b equals c. So addition is the operation that we need to undo. So we have to think in our heads, what's the opposite of addition? And that would be subtraction. So this would be minus b minus b. We have to subtract b from both sides to get a by itself. Note what happens. These cancel, and we're left with a equals c minus b. Awesome. So we solve for a. Now we just have a equals, so we've solved for a. Let's look at number two. Number two, we've got a divided by b, or a over b is c. So again, this fraction bar is the same thing as division. So we're doing a divided by b here. So we want to think, what's the opposite of division? And it turns out the opposite of division is multiplication. So we will multiply by b on both sides of the equation here, and that will cancel these out like before. And all we're going to be left with is a equals c times b. Or you could write b times c if you want to be alphabetical. But multiplication is commutative, so either of these is correct. Next, we've got number three, and we have a times b equals c. So whenever two letters are next to each other like this, assume that it means multiplication. So I'll do it for emphasis, but in general, if there's not a multiplication symbol in between, assume that's what's going on. So we have a times b is c, and we want to solve for a. Well, similar to how we did last time we had a division problem, so we multiplied. Here, we've got a multiplication problem, so we need to divide. So to get a by itself, we really need to divide both sides by b. Both sides of the equation by b. So this side and this side. And after doing that, we get a equals c over b. Awesome. All right, next, number four, we're going to solve for y. This is actually the equation of a line, but without going into too much details there, what we're wanting to solve for y here. So this one's more complicated than the previous three. This one's called a multi-step equation. Notice that problems 1, 2, and 3 only took a single step to get us to the final answer. Here we're going to have to do a couple of steps. So let's see it in practice. So we want to get y by itself. The first thing we'll want to do is we kind of want to think of, if you've ever heard of the phrase, please excuse my dear Aunt Sally, for the order of operations, for parentheses, exponents, multiplication, division, addition, and subtraction, that's P, I'll write it P-E-M-D-A-S. Well, when you're solving an equation, you kind of want to do the opposite of please excuse my dear Aunt Sally. You want to first, since we're solving for y, we want to first get this term out of the way. So we first get this term out of the way. These two terms are connected through addition, right? This is positive 2x plus 3y. So to cancel out 2x, what we'll do is we'll subtract 2x from both sides of the equation. Upon doing that, 2x's cancel. We bring down the 3y. And over here on this side, we have 4 minus 2x. All right. Now the last thing to do is to get y by itself with one more step. We have 3y. Remember, when a number and a variable are next to each other, or two variables are next to each other, this means multiplication. So this is 3 times y equals 4 minus 2x. So to get y by itself, we must first divide by 3. So then we get y is 4 minus 2x all over 3. And that's really all we have to do, right? All we had to do was get y by itself, so I'm just going to leave it like that. You could take this a step further by splitting this up into 2 fractions, but I'll leave that to you if you're curious about that. All right, now in our last example, we have a simple interest formula here. This is the amount of money you'd accumulate with simple interest. So simple interest essentially is through this formula, and essentially it gives you the same amount of interest every year, as opposed to compounded interest, where the amount of interest increases after each compounding period. But for putting aside all of those details, again, we're focusing on the formulas here, not the details or the background of the formulas. So instead, we're just going to look at this like we're just going to solve for p. So we've got p in this equation here and here, right? We want to get p by itself. So here's where we're going to come back to some factoring. Since both this term and this term contain p, we'll factor that out of both terms. So we take a p out, so we have a equals p parentheses, and now p goes into p one time, so we put a 1 here, and then there's a plus sign, so we need a plus sign here, and then p goes into rt times. You can kind of imagine like you're just covering up the p and then seeing what's left over. So if I covered up p here, what's left over is just rt. So that's what goes there. Awesome. So now we have a equals p times quantity 1 plus rt, and we have a multiplication there. So we must do the opposite of multiplication to get p by itself. So we can do this all in one step. What we'll do is we will divide by 1 plus rt on both sides of the equation. After doing that, these cancel, and we're left with p equals, I'll write it down here too, p equals a over 1 plus rt. Awesome. And then I promised in the last video that we'd look at some kind of an application of these formulas. So we're going to use the formula p equals, we found out the formula was a over 1 plus rt. We're going to use this formula to determine how much you must invest to earn $100 after 2 years at a 10% interest rate. So this sounds like a lot, but we're basically just saying that the A, this is A is 100, T is 2 years, so that's a T right here. T is 2 years, and then little r is the interest rate of 10%, or as a decimal, that's 0.1. So we're going to plug in all of this information into the formula we just found to determine how much money we would have to put in, or how much money we'd have to invest to end up after 2 years with $100. So let's do it. So we take P equals, we want $100, that's A. And on the bottom we'll have 1 plus RT, but that's 1 plus 0.1 times 2. All right, well that's the same thing as 100 over 1 plus 0.1 times 2 is 0.2. So this is the same thing as 100. Oh, sorry, I'm off the screen there. This is the same thing as 100 divided by 1.2. And I'm just going to pull out a calculator at this point because I'm not quite sure what 100 divided by 1.2 is, and that's totally fine. Calculators are not prohibited in this class by any means. So 100 divided by 1.2 gives us about 83.3 repeating dollars. Or in other words, because we're working with money and we can't really have repeating decimals with money, right? So I mean, at least not at least usually they round things off. So anyway, we can say that this is the same thing as $83.33 approximately. We just round to the nearest hundredth with money usually because we want to talk about dollars and cents. So yeah, that's it for this video. It was a little bit longer, but this is the end of section 1.5. And then in the next video, we're going to look at section 1.6, which gets into exponents and exponent properties and things of that nature. So if you like the video, please leave a like and subscribe to the channel, and we'll see you next time.